Hamming distance. The Hamming distance between two integers is the number of positions at which the corresponding bits are different. Given two integers x and y, return the Hamming distance between them. So when we look at the example, we have integer 1 and 4, and then we need to return 2. How can we get 2? So we need to convert this 1 to our bits, and then binary numbers, and then 4 we will change to the binary number, and then we will see how many numbers, how many bits are different. So 0 0, they are same. See here, the second index, the second position are different, so count is 1, and then this is the same, this is the difference, they are different, so the second and the fourth one are different, so we got 2 counts which are different, right? So we need to return 2. When we look at this example 2, 3, so when we change 3 0 0 1 1, right, and then 1 is just 1, right, 1. So how many elements how many elements are different? Only this third index, right? They are the same. So okay, how can we, so we need to return 1 because only that third index, the bits at the third index are different. That's why we need to return 1 because only one position are different. Okay, so how can we know that? It is simple. We can in our bitwise operations, we can do with the XOR we can know which elements are different. Only when the bits are different we will get 1, right? So for example, now 0 0 XOR will return just 0, 0 0 will return 0, 0 and 1 they are different, so we will return 1 false, right? And then if they are true, 0, right? XOR is like that. True and true, it will return true. False and false, if they are same, true. Only one is true and false, or false or true. Only at the time it will return false. So we can do the import integers with the XOR bitwise operator because we can do that in our C#, right? So I will create just a reset, just 0. This is to return our distance count, the Hamming distance. Okay, and then I will create the XOR, and then I will use bitwise operator. So we don't have to care about how can we get that, right? So here, if we, for example 1 is 0 0 1, right? 0 0 0 1, and then 4 is 0 1 0 0 0. Other time when we did, after we did the XOR, we will get like this 0 sorry, here is like this, right? 4 is 1 0 0. Okay, it's too much. Okay, and then we will get like this. So this one is the XOR, and then we will check how many ones are there, because we filter the different bits, right? So 1 there's are 2 ones, so we will return 2. Okay, so how can we know how many ones in these strings? So I will just check this one, and then I will make an operation with n. An operation with n means we will just do that after we did n, we will just know the last bits is 1 or not. If the last bit is 1 and 1, it's gonna be just 1, right? If it is 0, we will get 0, right? So by doing that way, we can know, we will check 1 bits by 1 bits, and then after we check this one, we will remove the last bit from our bit, and then okay, and then I will check the last one first. If it is 1 or not. If it is 1, okay, if it is whatever it is, we will remove after we checked, and then we will remove after that, and then we will remove this one. Okay, so until we reach the 0, I mean, and until even if it is greater than 1, and then we were just continuing, right, and then looking for how many elements, how many ones are there. So I will loop while our XOR value is still greater than 0, we will keep looking for, right, and then I will just add to my result by doing our XOR and 1, so we know the last element first, right, and then I will move the XOR to the right shift one place, right, only one place to the right side, and then return reset. Okay, I'm gonna submit this one to see what will happen. Okay, so I'm gonna submit. Okay, cool. So that's it. Thank you. So for the last case, I would like to explain again. If x is 1 and y is 4 at the time, our XOR value is gonna be, what is that? 0, and the XOR value is gonna be 1, 0, 1, right? And then in this while loop, and then we will have the result and our XOR values, right? And then result, it's gonna be XOR and 1. XOR is 1, 0, 1, and then when we make an operation, we will get 0, 0, 1, right? This is just 1. So 1 plus 0 return is 1. Okay, and then we will shift our XOR value to the right side one place, so XOR will leave only 1 and 0. Okay, the right most bits is gone because we shifted, right? And then we will check again XOR and 1. Okay, now XOR is just 1, 0, and then 1 at the time we got 0, 0, so result will not increase. So, and then we will shift again to the right side one place, right, and then we leave only 1 at the time. We will make an operation with 1 at the time we got 1, so we will increase our result 2. Okay, and then we shift it, so 0, so it is not greater than 0, so we stopped, and then we return our result 2. Okay, so that's it. Thank you.